We're going to start on question 3. Now the question 3 is asking us to calculate the surface area. I was a little bit disappointed about how some of you answered this question. What you need to do is to find the surface area of a sphere. So in the formula booklet, there's a really clear formula which says the surface area of the sphere is 4 pi r squared. So this is what I would do. I would do 4 times pi times r squared. And it's given here as r is this value. So substituting this into the equation, 4 times pi times 6.38 times 10 to the power of 3 times 6.38 times 10 to the power of 3. This is how we would find the answer. Now that's quite straightforward. Let me show you how I'd type this on the calculator. There's several ways of typing this in the calculator. If you're going to do it all in one step, what you need to do is to put the standard form in brackets as following. However, I would perhaps work these out as normal numbers first. So, if we press y equals, or if we look for the particular mode, and we want it to be in normal mode because we want to go from scientific to normal, let's see if this works on the calculator. 6.38 times 10 to the power of 3. That is 6,380. If you've got that in your head already, because you understand how standard form works, you don't need to do it on the calculator, and this will save you a bit of time. So I would then type this equation in the calculator, nice and easy, press enter. That is our answer. So the last step then is to write this in standard form. I was disappointed about how some of you couldn't remember how to do this, so I'm going to remind you here. We're now going to change the mode back into scientific. The way we do that is we press the arrow across key, press enter, press second quit. We're going to type in the number again, copying exactly as you can see above, and press enter. And it says 5.1150657 times 10 to the power of 8. E just means times 10 to the power of something. So for part 2, you would write it as follows. 5.11 times 10 to the power of 8. Obviously, in your actual exam, you'd write this as a power, not using an arrow up. Now let's cross-reference the mark scheme. So this is question 3. On question 3, we can see this is what the marks are gleaned for. The first thing is for writing down this equation. Now, it doesn't need to be exactly like this, because what I've written is exactly the same. Then your second mark is for writing the answer. It's allowed you to write it with lots of numbers, or it's allowed you to round it. Please note that at the beginning of the exam, and I need to talk to you more about this, it says unless stated it should be given to 3 significant figures. So going back to question 3, you are allowed to round this to 3 significant figures, which gives us 512 and then 6 zeros. Therefore, your answer can either be rounded or non-rounded, and you get 1 mark for the 5.12 or the 5.11506, and you get 1 mark for 10 to the power of 8. It says the surface area of the Earth is covered by water. Calculate the percentage of surface area of the Earth that is covered by water. Now, I was disappointed because some people automatically went to the percentage part of the formula booklet, but this is not necessarily percentage error, and it's not percentage error because there's no word which says error in this question. So this is what you need to do. You need to take the 3.618 times 10 to the power of 8. You need to divide it by your answer and times it by 100. This is M2 prior knowledge. And the reason why it says that we have got the water, let's perhaps colour this in blue so you can remember and understand that this is the water, is this amount. And we know the total surface area is this amount. So whenever we're doing percentages, we're going to say how much of the water is a percentage of the whole amount. So with percentages, you just do this one amount divided by this amount times by 100. If you're struggling with this, please check out my percentages videos on YouTube. If you got the previous question wrong, you can still do this question. You get a thing called a method mark. If you substitute the answer you got for part 2 into part B, you will get both of the marks, which is really, really cool. Now, question 4 was the hardest in the exam, I believe, and perhaps you would have struggled a little bit with this question. Most of you managed question 4A. However, you didn't quite write your answer like this. Remember, when we're doing algebra, this is really, really important. If you've got 150m, you always write the number first and then the letter. Again, this is prior knowledge from MYP. The reason why this question works is because effectively it wants us to substitute this number 150 and this number 180 into this equation. I thought this question was quite difficult because you really had to read carefully. This is the length. 150 is the length of the iron bar. And therefore, you need to substitute that in for capital T. Now, no, I've made a mistake there. The length is 180. So you substitute that in for L, the length. The temperature is T, so therefore you substitute it in for this capital T, which is why we get 150 instead of the T. And the reason why we swap them round is because this should be 150m and numbers always go before the algebraic letters. That is what you need to do for 1 mark. I was kind on the marking for this. If you wrote M 150, I gave you the mark this time, but in the real exam, you might not get the mark. Now we need to do the same thing again. We need to form another equation. So we need to substitute the two things in. We need to substitute in the length of 181.5 equals 210 m plus c. Now, unfortunately, the mark scheme didn't actually give you any marks for setting up that equation, which I thought was a bit mean. So in order to solve this, you need to work out what m and c is. We have 2 equations, so this is clearly going to be a simultaneous equations. So what we need to do is we need to go to apps. We need to go to polysmelt, I believe, which is number 9, simultaneous equation solver, which is number 2. Now in this equation there are 2 unknowns, m and c. There's 2 equations, so we press next. We then need to copy in the equation. Remember, it's set up with the 2 terms on the right hand side equaling a term on the left hand side, so you need to swap these around. The first one's going to be 150. Now it says x, but that's fine. The next one's 210. If you're struggling with this, there are 2 videos on my YouTube channel called Simultaneous Equations with the TI-84 calculator. What you may not have realised is that this question is a simultaneous equation question, which is why you might have struggled. Again, this is 1C. If you know how to solve these algebraically, that is absolutely fine, but I think it's easier to use the calculator. Then we're going to have the top equation is going to be equal to 180, the bottom equation is 181.5. Make sure it's displaying properly, then press solve, which is the top right button, which is graph, and it gives us the answer. Now that doesn't look quite right to me. Let me just double check the mark scheme. Indeed it is correct, and you would get the answers for that, but that might look a bit strange. So let's write down the answers. X equals 1/40th, Y equals 705/4. So we're going to quit out of the menu now. And you could leave your answers like that, but you might want to leave it as a decimal. Let's have a look at how we would write this as a decimal. We'd click on the math button and we press fraction, which is number 1. And we are going to type in 1 divided by 40. And that gives us the answer. It's 2.5 times 10 to the power of -2. And then if you were to write that as a decimal, hopefully you'd be able to understand it's 0.025. Again, you could do this by changing the mode of the calculator, changing it to normal mode, press enter, enter again, there we go, 0.025. So it's a lot of steps, but actually you can just leave your answer like that. You could do the same for the last one, and these were the answers you would get. The last thing you then need to do is substitute it back into the equation. So you take these two values, 0.025, and the second one is going to be 165.25, and you substitute it back into the equation. So it wants us to find what happens at 40 degrees, and we'll go through that in a moment. Substitute these two special values you found, 0.25 and 176.25, into your equation. So they've done it in a bit of a strange way, and I perhaps wouldn't do it quite like this. This is how I would do it. I would take the 0.25, we would then times this by 40, and then we're going to add finally the 176.25. And the reason why we've doing this is because we want to find it at 40 degrees. We now know what M is, we now know what C is, and we've got the given temperature of 40. So we substitute in the M and the T here, and then finally we add the C, which is 176.25. Now in the exam, if you got these numbers wrong, but you substituted something in, I would give you the benefit of the doubt, and you might have got some marks here, which would be fantastic. So on the calculator, this is how you would do it. Finding our calculator underneath here. We are going to type in the following: 0.25 times by 40, then we're going to add the 176.25, and you'll see we'll get the answer here. You can see here I've made a little bit of a mistake, so let's just double check. It's absolutely fine to make mistakes as long as you understand where you've gone wrong. I think it would have been better if I put this into brackets. So we're going to get 0.25 times by 40 plus 176.25, and you can see that our answer is the same because it has applied BODMAS, it's done the multiplication first. So actually there is some sort of error in this answer. So if you did get 186.25 in your exam, you might be due a few more marks, so let me know. Let's go over the next question promptly. The next question we're going to go over was one which was done not ideally. So this is a cumulative frequency one. Now, in practice, this is quite straightforward. It's to do with buses and the distance these different buses travelled. For this one, we don't need a calculator for, so let's just zoom in. Find the number of buses that travelled between 15,000 and 2,000 kilometres. So the way you do this is you find the two key bits of information on the x-axis, 15,000, that's a great straight line, thank you for technology, and then you draw a straight line going across, and then 20,000 up to the line here, and then going across here. Now, in order to find the answer, what you have to do is you ask yourself the difference between the 20 and what we'll end up here. So let's have a look at the mark scheme. In our mark scheme then, for question 8, we are going to have the following. 8a is 8. The answer is 8, and that's not too much of a surprise. The previous screenshot was a bit rubbish, so let's do another one again. So we're going to go between 15 and 20,000. If we go up to the straight line and across, we're going to land on 20. And then if we repeat that process again, 20 all the way up here to going across, jumps, so that's going to be 28. So it's the difference between 20 to 28. So if it's asking you to be between two values or greater than a particular value, between two values you would go up from one of the values and across, up from the other value and across, and then count the difference between these two values on a graph. If it was asking you for buses that travelled more than 15,000, you'd go up and across, and then you'd count the difference between 20 to 30, which is the maximum. So that would be 10. Now, the next question says, use the cumulative frequency to find the median distance. Again, really quite straightforward. Median is halfway across, so you find the 15, you go across to the 15 and down. And it's going to be somewhere between 10,000 and 15,000. And clearly this is probably where some of you struggled. So I'm going to zoom into this section for the next part. And we're going to go across the 15 and we're going to go down. So this is where we land. So we're going to say that this part here is going to represent halfway between 10,000 and 15,000. And because we're, again, 6 boxes out of a total 10, it's going to be 6, this is another way of thinking of it, 6/10 of the total jump. Now the total jump, what I mean by that is how many numbers are between 10,000 to 15,000. Well, there's 5,000. If you can't do that in your head, you can use a calculator. So it's going to be 10,000 plus 6/10 of the jump, which is 5,000. 6/10 of the 5,000, you can do that on your calculator. 6 divided by 10 times 5,000. Or I'm going to do it quickly now, and it's going to be 3,000, I believe. So let's just double check with the mark scheme. That sounds about right to me. So 10,000 plus the 3,000, which is the jump, is going to be 13,000. This is said 13,500. So I went a little bit wrong there, and you can see actually how easy it is to go wrong here. So let's go over this again. It's absolutely fine to go wrong. What you need to do is go a lot slower than me. I've realised exactly why I've gone wrong. Is because it's actually 7 boxes across, not 6. So it needs to be 7/10 of the gap, which is 5,000. And then that is going to allow you to work out the gap jump is 3,500. So you take the 10,000, you add on 3,500, and you get the 13,500. Let's go on to question C. Cumulative frequency to find the lower quartile. Again, we're going to practice this method. So 15, half of 15 is 7.5. Halfway in between 5 and 10. Nice and easy. We're going to zoom into this section. We're going to go across from 7.5 and we're going to go down. This one's really easy. It's on a straight line, therefore it is 10,000. We're going to now have a look at question D. Upper quartile, again the same step. So upper quartile is going to be to do with the 3/4 of the graph. This is quartile 1, 7.5, quartile 2 or the median, 15, quartile 3, 3/4 of the way up. So 22.5, we need to go 3/4 of the way up from the graph. So this is halfway in between 20 and 25. So halfway between these two numbers will take us here, and then we are going to go down. And this time I notice it's 2 boxes from the 15,000. So each jump is 5,000. So we need to find 2/10 of 5,000. 2/10 of 5,000. There might be another way you like doing this, but I think this is the easiest. This is therefore going to be 1,000. So this is going to be 16,000 after 2 boxes, because 2 boxes 16,000, another 2 box would be 17, another 2, 18, another 2, 19, another 2, 20. So you can always check your answer like that. So 16,000 for the upper quartile or quartile 3. Let's check on the mark scheme. Absolutely. Interquartile range, nice and easy. Interquartile range is always the upper quartile minus the lower quartile. Make sure you check on your exam to make sure I've given you the marks for this. Upper quartile minus lower quartile of your particular numbers. You select these two numbers and it's going to be 16,000 minus 10,000 is going to give us 6,000, which will be our interquartile range. So Professor Ficulum investigated the migration season using this formula. Now, because it's the power of a variable, where the variable is changeable, this is going to be an exponential function. So if it ever asks at the start of a period is when time is 0. So you get your calculator. There's so many ways of doing this. You're going to go onto the y equals. So we're going to type in this formula. I'm going to clear what's currently there. We're going to type in 1,350 plus 400 times 1.25 to the power of minus 0. Enter. Then you can do this a number of ways, but I think the easiest is to look at the table. So when we have the population is, or at the start of a period, it is going to be 0, our answer is going to be 1750. However, you can see there's an issue because these numbers don't change. So let's see where I've gone wrong. You can see I've substituted straight away the value of t to be 0, and I want to find the general case where it changes in the table. So let's substitute this for x. Go back to the table, and you can see at the start of the period, as expected, the population was 1750 or 1750. However, it changes and it decreases every year, year on year. And this is what the table shows you. So our answer to question A is going to be 1,750. Now for part B, find the population of the bulbul birds after 5 days. So all you need to do is get your calculator open, and I would draw a bit of this table to show you understand. You are going to select this number. Most of you got this. However, you cannot select a partial number when you're talking about population of something to do with population, such as birds or people. You can't have 0.1 of a bird. So what you need to do is take this. They've done it a slightly different way, and they've given two answers they can accept. So what I would do is I'd take this number and I would round down. Now, part C, calculate the time taken for the population to decrease below 1400. Now, this is essential. It decreases below 1400 on a day between 9 and 10. So most people wrote 10. This is incorrect because you need to give an exact answer. This is why it's 2 marks. And we went over this in a second YouTube video. This method of guessing it was 10, I accepted for the last exam. But for this exam, I showed you another method using YouTube and Edpuzzle. What you have to do is you have to go to y equals, you have to get a line which is 1400. You have to then click graph. I cannot see the graphs, so I'm going to shift them over. I want to see more of the x-axis. I'm going to go onto the x-axis. I'm going to shift it so it's between 0 because the population is starting from time 0 to, let's say, time 15. Now, the y, again, the y never becomes negative. It starts at 1750, so let's put this as 1800. That's not going to be the minimum, that's going to be the maximum. And let's say the minimum is going to be 0. So let's press clear, 0, 1800. Now we're going to press graph. Now, it starts decreasing below 0 after the intersection. So this is the population, and this is 1400. So below this line is when it starts decreasing. We want to find the exact proportion of days. Now, days is what we call continuous because you can talk about a part of a day. You can talk about days in terms of decimals. You can have 9.5 days or 9.37 days or 10.4 days. You can't have 10.4 birds. This is why you have to be exact for this answer. We would like to calculate something to do with this. So we press second trace and we want to calculate the intersect, which is number 5. You have to go onto the first curve. It's already jumped onto the blue curve. Press enter. We have to press something on the red curve. Let's press enter anywhere and then guess where they intersect roughly. They roughly intersect here. And you can see the answer, if I zoom in a little bit, is 9.3188512. So if you put 10 as the answer, unfortunately, that isn't the right answer. That was tricky, but please remember this for exponential models for the future. So now we're going to go over this question. Now 7b was not answered ideally. However, what you need to do is if it talks about outlier, you need to remember to use the outlier formula. You should have memorized this. Your outlier formula is going to be as follows. 1.5 times the interquartile range. That's the key part of it. And then you're going to have two parts of it. You're going to have the lower bound or the lower quartile minus 1.5 times the interquartile range. And then you're going to have the upper quartile plus 1.5 times the interquartile range. I've gone over this on my box plot and outlier video. Please check this out if you want further detail. You would have got 2 marks if you did something like this, and this was disappointing. You've already calculated the interquartile range. It's the distance of the box. The range is the distance between 0 to 39, and the interquartile range is the distance of the box, 4 to 11. 11 minus 4 is 7. Most of you did get that. So, another key thing to remember is that how much percentage of the data occurs in this box plot. 25% occurs here, 25% occurs here, 25% occurs here, and 25% occurs here within the long tail. That means the data is a bit more spread out here. Now clearly by just looking at it you can tell there is going to be outliers, but at what point do they become outliers? And that's what we need to decide. It says students sent K text messages where K is greater than 11. Given that K is an outlier, find the least value of K. So to me, when it's giving an inequality sign, it's talking about the outliers which are greater than what is expected rather than less than what is expected. So we're going to talk about the upper quartile plus 1.5 times the interquartile range. If you didn't know this, you could apply both of these formulas and you would get some marks in the exam. So we're just focusing on the bottom equation, which is something you need to memorise. The upper quartile therefore is 11. Then we're going to do 1.5 times the interquartile range, which you've already calculated, times 7. And we are going to have the following, 20.5. Let's just double check. My maths wasn't quite right. It was 21.5. So this means if this diagram is about students sending text messages, we've got the minimum amount of text messages sent is 0, the maximum is 39, and everyone else is in between. You can't send half a text message. That's not possible. Again, this is going to be a discrete variable because you can't send part of the text message. So when we're looking at K, for it to be an outlier, and if it's bigger than 11, it's got to be this number or bigger. Because we can't have part of a number, K at minimum is going to be 22. In terms of this diagram then, we're going to say that anything above 22 is an outlier. So anything in this section is an outlier. This is what we mean by this question. I hope you found this video useful and let me know if you have any queries.